Hello students, myself is G. Nikita, a pharmacy assistant professor in the Department of Pharmaceutical Chemistry. So, I will deal the pharmaceutical inorganic chemistry for Form D first year. So, today's topic is limit test for sulfide. So, today we are going to discuss about the limit test for sulfide. So, in last class, we have discussed about the limit test introductions and the limit test for chlorides. So in today's class, we are going to discuss about the limit test for sulfates. So the principle involved in the limit test for sulfate is the reaction is mainly based upon the soluble sulfates with barium chloride in presence of dilute hydrochloric acid to form the barium sulfate. So here the reaction is involved between the soluble sulfates with barium chloride. So the reaction will be occur between this sulfate and the barium chloride in presence of the dilute hydrochloric acid to form the barium sulfate. So if the barium sulfate has been formed, means there will be the formation of the white precipitate or turbidity in the solution. So if you see the reaction here, the sulfates. So when the sulfates, see here sulfates reacted with the barium chloride in presence of the hydrochloric acid. So we will get the barium sulfate and the chlorine atom will get separated. So here the sulfates will get replaced in the place of the chlorides, and these chlorides will get separated. So when the sulfates reacted with the barium chloride, we will get barium sulfate and the chlorine atom will get separated. So the main principle involved in the limit test for sulfate is the reaction occurs between the soluble sulfate with barium chloride in presence of dilute hydrochloric acid to form barium sulfate. So here if the barium sulfate has been formed, means the white turbidity or the precipitate will be formed. So this is about the principle involved in the limit test for sulfates. So the method for limit test for sulfate. So how we can able to prepare the test solution and standard solution. So let's see first test solution. So here we have to take the specified quantity of the substance, and should be to this we have to add water or the suitable solution in the Nessler cylinder. To this we have to add 2 ml of dilute hydrochloric acid. Then dilute to 45 ml with the solution. Then to this add 5 ml of barium sulfate reagent. Should be stirred properly and should be kept aside for 5 minutes. So this is the preparation of the test solution. So here we have to take required quantity of the substance should be dissolved in the water or suitable solution and should be transferred into the Nessler cylinder. And to this we have to add 2 ml of dilute hydrochloric acid and diluted to 45 ml with suitable solution. Then to this we have to add 5 ml of barium sulfate reagent and should be stirred properly and keep aside for 5 minutes. Next, we have to prepare the standard solution. So to this, in the standard solution, we have to take 1 ml of 0.1089 percentage weight by volume of solution. So here we have to take 1 ml of 0.1089 percentage weight by volume solution of potassium sulfate and 2 ml of dilute hydrochloric acid, and it should be diluted to 45 ml with water or suitable solution and add 5 ml of barium sulfate reagent and should be stirred and keep aside for 5 minutes. So in this way we have to prepare test solution and standard solution, and we have to compare both test and the standard solution. So whatever the turbidity has been formed in the test solution should not be more than the standard solution. So if it is less than the standard solution, means we can able to say that our limit test has been passed. But if the turbidity is more than the standard solution, means our test solution has been failed. See here the test solution and the standard solution. So in the test solution, we have to take specified weight of the compound and should be dissolved in the water or suitable solution. To this, we have to add 2 ml of dilute hydrochloric acid, and then we have to dilute to 45 ml in Nessler cylinder. And to this, we have to add 5 ml of barium sulfate reagent. Then the turbidity will be formed. Next, we have to prepare the standard solution. So to this, we have to add 1 ml of 0.1089 percentage weight by volume of potassium sulfate. So here we have to prepare the potassium sulfate solution. To this, we have to add 2 ml of dilute hydrochloric acid and dilute it to the 45 ml by using the solution and in the Nessler cylinder. Then add 5 ml of barium sulfate reagent. So we have to observe the turbidity. So we have to compare the test solution with standard solution. If the turbidity or the white precipitate in the test solution is less than the standard solution, means we can able to say that our test solution has been passed. So this is about the limit test for sulfates. See, I will explain again. The main principle involved in the limit test for sulfate is the reaction will be occur between sulfates and the barium chloride in presence of the dilute hydrochloric acid. So to form the barium sulfate. So if the barium sulfate has been formed, means white turbidity or the precipitate will be formed. So when the sulfates reacted with the barium chloride, so the barium sulfate and will be formed and the chlorine atoms will get separated from the barium. So the method of preparation of the limit test for sulfate. So how we can able to prepare the test solution means we have to take the specified quantity of the substance and it should be dissolved in a suitable solution. Then we have to add 2 ml of dilute hydrochloric acid. Then this solution should be diluted to 45 ml in the Nessler cylinder. And to this we have to add 5 ml of barium sulfate reagent. Then the turbidity or white precipitate will be formed. Next, standard solution means here we have to prepare potassium sulfate solution. So potassium sulfate solution we have to prepare. So from that we have to take 1 ml. So from 1 ml of potassium sulfate, to this we have to add 2 ml of dilute hydrochloric acid and it should be diluted to 45 ml in Nessler cylinder. So to this we have to add 5 ml of barium sulfate reagent. So the turbidity will be formed. So whatever the turbidity or the white precipitate formed in the test solution should be compared with the standard solution. So if the precipitate in the test solution is less than the standard solution, means we can able to say that our limit test has been passed. But if the turbidity or the white precipitate in the test solution is more than the standard solution, means our test solution has been failed. So this is about the limit test for sulfates. So these are the references books that should be followed for the limit test for sulfates. Thank you.